We now move on to our next speaker for the embryology session, Dr. Asif Khan. Dr. Asif Khan, consultant embryology at the Specialty Fertility and IVF Unit, Aster Medicity, Kochi. He will be speaking on the topic embryo stressors. Let's welcome Dr. Asif Khan to take the stage and share his insights. Over to you, Doctor.
Present view. Okay, sure. Thank you. Good morning, everybody. First of all, a big thank you for the Advances team and the organizers for inviting me, especially Jayakrishan sir. My topic is embryo stressors. So this is a very, it's a GLP oriented topic, so very extensive topic. So I will try to stick to the practical aspects of it. I'll be dealing more about the measures to be taken to reduce the stress of the embryos in the lab. So my main objective would be to identify the risk factors or the stressors, explain why they are important, the adverse effects, where and how to look out for, and the precautions that we should take, the do's and don'ts. So why are we concerned about the stress for embryos? There are a lot of studies with potential long-term responses like reduced implantation, unbalanced fetal and placental allocations, epigenetic modifications, so on and so forth. There is a lot to address. So I will stick to the practical aspects. So these are the main in vitro stressors. Out of that, the temperature, pH, osmolality, air quality, etc. Deserve the most importance. So I will be sticking on to them. So the problem is many of these factors, they interact together, and that makes ART more difficult. These effects may not be even expressed as fragmentation or cleavage arrest, but will affect the embryo viability, implantation potential, and the health of the offspring. So moving on to pH, it's a measure of hydrogen ions. It's a known fact that the pHi, that's the resting internal pH of the embryos, is 7.1 to 7.2, and the embryos grow optimally in a pH of 7.2 to 7.4. So why is pH important? Of course, the embryo development can be influenced by the pH of the medium. Denuded, for example, denuded mature oocytes, they lack the regulatory mechanism to regulate the pH, that's the pHi, which are mediated by the cumulus cells. And it's activated only almost 6 hours after fertilization. Same goes to the cryopreserved or thawed embryos. They also have a reduced ability to regulate pHi. So a proper and stable pHe is crucial. So the extracellular pH, because we cannot alter the pHi, we can only change the pHe. So thereby the pH checking becomes an essential tool, because a small deviations in pH are actually large exponential changes in hydrogen ion concentration. So a stable pH is essential to optimize the optimal embryo development. There are many methods to measure the pH. The most common ones are the benchtop pH meters. So these are some of the, I don't have any special interest in any of these pH meters or any gadgets which I show. That's a disclaimer. So these are some of the pH equipments which I have used in my experience. So some hospitals, some centers, they use ABG machines, even handheld machines. It works well for them. And there are also online pH meters. These are more expensive but very accurate, and which can avoid the pH drift that the other equipments have. So in the picture, what you can see is a SafeSense probe. It has 8 probes connected to a track station and gives a continuous pH reading in constant intervals. There are other online pH meters also, like Signify and ones by MTG. So another important thing is the pH decreases with rise in temperature. So this is especially true when the pH is above 7. Hence the pH measurement should be done at 37 degrees Celsius and not in room temperature, or the pH meter should have a temperature compensation electrode. If you are using a pH meter, which is what we commonly use in most labs, you may have to replace the electrode, which is very important. It's not an one-time investment. You have to replace the electrodes in every 2 years or so, or according to the manufacturer recommendation. But if you take care of the electrode well, you can prolong the life of the electrode. I am not going into these details. So the recommendations. So how you check the pH is also very, just as important, and how it should be performed. So the pH meter should be calibrated each time. It shouldn't be calibrated only once in a month or so. It should be every time you take the measurement should be calibrated, and it should be calibrated using fresh buffers which are warmed prior, ideally at 37 degrees. The bracketed range of pH buffer should be according to the pH. So for example, we are looking for a pH of 7.2 to 7.4. So we should be using 7 and 10 ideally, or if possible 7, 10 and 4 also. And always use the same media with protein, not without protein, and not some other media. You can use the media from the previous batch if it's not too old or if the color change is not too much. Always avoid pH drift by reading quickly or placing the meter close to the incubator. Always simplify pH testing. It could be a bit complicated for some lab personnel, so always have an SOP, simplified SOP for all lab personnel. Always test each incubator and each batch of media. Check pH routinely. It could be weekly, bi-weekly, according to the case load. So what are the PHE recommendations? To reduce the stress, PHE should be as close to the PHA as possible, or slightly higher than the PHI. Always follow manufacturer recommendations for optimal pH, because each manufacturer will have their range of pH. For example, some media companies, they might advise you to keep the pH at 7.28 to 7.3. So this will give you a better control for optimal growth. Some manufacturers also recommend a high-low-high paradigm. This is especially true for sequential media, but it may not everybody agrees. It may not agree with in vivo conditions. So the best practice is to keep PHE in a narrow range. So there are three identified stages of media pH: equilibration, set point, and stabilization. It's very important to understand these three phases in a culture media. By checking the pH of actual media, we can only confirm the set point, but maintaining it will be the tricky part. pH equilibrium. Coming to pH equilibration, it takes more than 8 hours. We call it overnight. It can depend on, it can vary with the dish that you use, if it is with lid or without lid, depending on the media volumes, the oil volumes, whether it's pre-equilibrated oil, that is gassed oil, or the if you are using fresh media out of, if it's a gas media that you are buying from the commercial available manufacturer, then again the time to equilibration can reduce. So this is a very interesting graph from Jason Swain. It shows that the equilibration can be achieved faster if you are not using the lid, or if you have the lid gap. Some take-home points regarding stabilization. Always minimize the incubator openings to a minimum. Have more number of allot more incubators depending on the case load. Ergonomic positioning of the incubator. Having dedicated warmers will again help. When you are working outside the incubator, work quickly. Use adequate oil overlay. Using isolate chambers, of course it's expensive, but that is the best thing that you can do. If you don't have isolate chambers, use proper buffers like Switter ions. So what are Switter ions? They give a stable pH outside the incubator. There is no need to give it CO2, no need to gas it. So if you don't have isolates, this is perhaps the best thing that you can give the embryos. But you have to maintain at 37 degrees. So Switter ion buffers are commonly, they are the heaps and mops that we commonly use. Coming to the next one, temperature. We all know the irreversible damage that variations in temperature can cause to meiotic spindles and microtubules of the oocytes and embryos. So there are many studies showing suboptimal development when the temperature spikes, or there are suboptimal temperature conditions. So what is the correct temperature that we should use? Is it 37 or is it less than 37? So we all know our core body temperature is somewhere around 37. But a temperature gradient exists in the female reproductive tract. but it's practically difficult to maintain different temperatures. Of course, there are a lot of studies showing that it's difficult to maintain different temperatures, different stages of development. So it's always best to stick to a temperature as close to 37 as possible. Some studies show that the optimum temperature range is around 36.8 to 36.9. So this is where the equipment calibration is very important. So it's not that you have to check equipment, the temperature of one or two equipments every once in a while. You should monitor it very closely. So these are the most important equipments that I think most of us know about this: incubators, heated stages, warming blocks, refrigerators, and even the ambient temperature should be controlled. It's prudent to employ double control or triple control on key equipments, especially the incubators. You can have additional sensors or data loggers depending on your, and alarms depending on your setup. The most widely used QC tool for temperature is the thermocouple, which you see in the picture. But it should be periodically calibrated. It's very important. It should be calibrated at least once in a year. Many of us depend on engineers who come do the external audit and do the QC. But we should make sure that they also do this procedure, that they calibrate their equipments. We take it for granted that they do it. But I would like to know how many embryologists are here. Not bad. But I'll include Parishu also. Okay. Okay. So what is the most important tool to check the temperature in your daily routine practice? What is the most common thing that you think is important? Okay, the most common, it's a bit off record. The most common tool that I think is a dorsum of the hand. Because you cannot carry the thermometer along with you or the thermocouple, so you should be aware. So that's what I tell all my trainees, that you should be aware of your surroundings, and so it should not just the temperature, everything. So when you're calibrating large heating stages like the laminar flow heating, so it's quite a large area. So that's what I have shown in the picture. You have the stereo zoom microscope and the right hand side and the left hand side. Ideally you should have three separate sensors, temperature sensors. The manufacturer or the laminar flow should have three separate sensors for the stereo zoom microscope, that is the heating plate, and right hand side and the left hand side. Some manufacturers, they just have one sensor, and the problem is there is a large temperature variation happening across the table. So if the variation is more than if it is around 0.5, it is okay, it is normal. If it is more than 1 or 2 degrees, then there could be cold zones and hot zones. So only if you map it when you're doing the calibration, you can detect all these things. Because we all have many of us have a practice of, because of the lid gap under the because of the dish gap, air gap under the dish, we commonly increase the temperature of the laminar flow to 38 or 39. Some people even keep it at 40. So it's very important to identify these spikes. If it is more than 2 degree variation, then you should consider replacing the heating element or discuss it with your supplier. So these are some new gadgets which I saw yesterday. This picture I took this picture yesterday mainly to show this air gap under the dish. So you can see that the dish is in contact with the heating plate or the heating surface only on the edges, not in the center. So and the heat escape is happening, heat radiation is happening, evaporation is happening, especially if you are not keeping the lid on when you are keeping inside the laminar flow. This is even more prominent. So this is I have not used this. I came across this only yesterday. It's a dual channel digital thermometer. They have incorporated the probe in the dish. So it looks very promising. Coming to take home regarding temperature, working in isolates or humidified chamber is the ideal thing. Keeping a bench of warmer or a mini incubator inside the workstation or your laminar flow will be very good. which is not very expensive also. Raising the surface temperature of warm stages more than 38 degrees can help to counter this air gap and thermal conductivity. Using when you're handling dishes in and outside out of the temperature, then you can use the dish inserts to maintain the temperature. Keep the dish on, lid on, especially in the lathe. And when you're culturing with micro droplets, avoid the micro droplets towards the dish margins. They are cold zones. Reducing the time of exposure outside the incubator. Again, optimum oil overlay, routine QC of all equipments. Ambient temperature also is important. Using benchtop incubators and time-lapse systems can give you better temperature control along with pH control. And of course, most important is reliable online UPS. Coming to osmolality, just a few important points regarding osmolality. Optimal embryo development requires a range of 255 to 295 milliosmolar per kilogram. Most commercial media companies, they have a range within this. All their media suit, it has a similar milliosmolar range. So the take-home messages regarding osmolality. Since we use commercial media, we just have to take extra precautions in handling during procedures, and most importantly the dish preparation. So when you're doing the dish preparation, switch off the heating, switch off or reduce the flow of the laminar flow while doing dish preparation. Optimize the droplet volumes to 25 to 40 according to studies, and according to the embryo numbers, you can optimize the drop volumes to 25 to 40, not less than 25. Optimize the oil overlay volumes, because the oil to act as a heat sink and to have a protective effect on the embryos, it should be at least 3 millimeter above the droplet. I always say 2 operators are best for dish preparation, because when one person is doing the dish, the other person can overlay the oil. Optimize the media order based on cases. Frequent bottle openings reduce the osmolality. Some people aliquot, which is not recommended. So it is depending on the case volume, you can order 10 ml or 20 ml media bottles, which will help. Take extra care during post denudation and vitrification and warming. I'll move on to the human factors also. There is a lot of stress. It could be technical issues which contribute to the stress of the embryos. The sterile practices that we follow, traffic inside the lab, too many people inside the lab, the ergonomic positioning of the equipments is not ideal. Then it could be errors in labeling or documenting, time of exposure outside control environment when you are manipulating the embryos. Then displaced or misplaced droplets. Some embryos could be lost because of that. These are all things that can happen in daily life, which we try to avoid every day. And culture, that is the shape of the culture droplets, air bubbles in culture droplets. So the culture droplets, the curvature of the culture droplet is very important. So I always say a good dish is a job half done. I'm almost done. Yeah. So a good dish preparation is a job half done. That's what I always say. So again, oil spillage, oil overflow, absence of a lid gap, maybe too much oil is under the lid is sticking to the dish. These are all issues. It can even lead to dropping the dish. To conclude, ART is a dynamic science. We all know that. So we keep ourselves updated and question ourselves every day. So we cannot take another person's or Western hospitals SOP just like that. So we have to adapt to it, but we should stick to it. Double witnessing is very important. We should be cautious. I know we are all very, embryologists are generally paranoid, but it should not be on the edge. Then timely reporting is very important, not just observation. You should report timely to your seniors. Then only proper action can be taken and it can be avoided. Documentation is very important because it helps in troubleshooting. So I always tell my trainees to think like the embryo, talk to the embryo, and never trust displays blindly. So I've been talking about stress to the embryos, but what about the stress to the embryologists? So again, keep enjoying what to do, and wishing you many more healthy babies. Thank you.
Thank you so much, doctor, for that enlightening session.